Thank you, Sir Jonis. Good morning, everyone. I would like to welcome our two very special visitors this morning. We have our very able Education Program Supervisor for Science of the Bicol Region, Ma'am Chisara Chi Doroy.
Thank you, Lynn. Morning, good luck.
Thank you po. We also have an equally able Education Program Specialist of SDO Tabaco City. We have Ma'am Tess Buasan.
Good morning, everyone. Good luck to everyone.
Thanks po. And also the members of the IT team, both from SDO Tabaco City and Tabaco National High School. And of course, you, our dear grade 12 STEM students. How's everybody? As of the moment, we are only 31 in the meet, so we expect more to be joining later as we proceed with our today's engagement. All right? To begin with, all right. Welcome to one of your specialized subject in grade 12, being a STEM student. That is General Physics 1. And this is Ma'am Analyn Borlaza, your subject teacher. Relax, enjoy while learning. But before we begin with our lesson proper, may I remind everybody once again of the different online house rules. First, remember to be polite at all times. Second, pay attention to the presentation. Third, participate, whether it is an individual or a group activity. Fourth, if you need to ask questions, switch on your microphone and you will be acknowledged. In our class, if the teacher poses a question which requires an answer needing elaboration or explanation, you can switch on your microphones. On the other hand, if the question simply requires short answers, you can just give your answers through the chat box. I hope that is clear. And whenever it's not needed, you have to keep your microphones on mute, but turn on your camera, please. And lastly, follow the 20-20-20 rule. I hope you are already familiar with the 20-20-20 rule. Let me briefly explain. Just in case I become too engrossed in our discussion, 20-20 rule means after 20 minutes, you have to look at objects which are at least 20 feet away from you. In that case, if you are looking at objects that are that far, you are relaxing the ciliary muscles that holds the lenses of your eyes for 20 seconds. So, even if sometimes I forgot to remind you, I hope you will practice this. Is that clear? All right. To begin with, have you met Lord Kelvin before in your science classes in the lower grades? Or his real name is William Thomson? Ah, probably to some yes, to some no. You can answer me also through the chat box. I am monitoring your responses in the chat box. Lord Kelvin is a British mathematical physicist and mathematician who once said, "When you can measure what you are speaking about and express it in numbers, you know something about it." What do you think is Lord Kelvin trying to convey in this statement? Anybody? Anyone who can explain? What do you think is Lord Kelvin meaning for this statement? Anyone from the class? As if no one is ready, may I call on Carl? Carl Vincent? What is your idea of this statement? I guess Carl is not ready. What about Daniel Alejandro? Dan, what is your idea about this statement?
My idea about that statement is that, um, as you've said, when you can measure what you're speaking about and express it in numbers, you know something about it. What I understand from this is that, when you know the details about a specific subject or a topic, you have knowledge, you have a deep knowledge about it.
Well said, Dan. Yes, meaning one gauge for somebody to tell whether you know really something of what you're speaking about is you must be able to measure it. What about somebody from the girls? Let's have one from the ladies. Volunteer? Once you are reciting po, kindly switch on both camera and microphone so you will be acknowledged. Your classmates could see you also. From the girls, Ella, can you try? I am not receiving any response. So anyway, now I agree. Dan is right in saying that for someone to tell that you know indeed something about a certain thing, you must be able to measure it, you must be able to express it in numbers. In other words, Lord Kelvin is putting so much regards in measurement. Measurement is the very first chapter of your general physics course. And for today's lesson, our main objective is, anybody please who can read po? Irish, can you please read? Irish? No response from Irish? Ay, sorry. Sige, go ahead po, Irish.
Involving conversion of
Continue.
expressions of measurements in scientific notation.
Thank you very much, Irish. Now, this is quite a broad objective, and we shall dissect this into two. The first part, which is on conversion of units, will be the focus for today, while that of scientific notation will be for the next meeting. But of course, we subdivided this into simpler objectives such as number one, John Renzi, can you please read? What about William?
Yes, ma'am.
Yeah. Yes po, kindly read. That's right. Please proceed to the second objective.
Differentiate base from derived quantities, scalar from vector quantities.
That's right. And the third?
Convert units, convert units both for base and derived quantities.
And the last one?
Apply conversion of units to some real-life situations.
Thank you, William. Okay, so these are our targets for today. To begin, what is your idea of measurement? This is a very common term in the field of science, but how do we define measurement? How do we define measurement? Don't first, camera is switched on. Don't first, would you like to say something? Your microphone po is switched off.
Wala po, ma'am. Napindot lang.
Wala pong? Come again?
Napindot lang po, ma'am.
Napindot lang. Okay, anyway po, napindot na rin lang naman. So what is your idea of measurement?
Measurement is ano, the it's like how long something is, or the size the size the size of something.
Okay, yes, you have an idea naman. Very good. Thank you, Donfer. According to him, it is how long something is. So he is specifying something, and that is length, probably based on the illustration given in my PowerPoint. When we say measurement, it is actually a collection of quantitative data. When we say quantitative data, they are expressed in numbers. Or It is also a process in which you compare an unknown quantity with a standard unit, like consider the length of a string in this picture. It's the length which is the unknown and which provide a standard unit of measure. It is the meter stick. And take note that every measurement is composed of a number and a standard unit, such as, so you'll see here, this 30.6 is a number showing the amount or the magnitude, while this grams shows the standard unit. Take note po, it has to be a standard. Okay? Then, in the Philippines, how many systems of measurement as of the moment are we using? I can entertain questions through the chat box po, my dear students. In the Philippines, how many systems of measurement are we using? Donfer, microphone is switched on. Yes, Donfer? Biglang na-mute ulit. Okay. Any idea? Systems of measurement the Philippines is using now or for many years already? We have two po, ma'am. Very good, Carmela Grace. Can you name them? Can you name these two? Probably Carmela is still typing her answer. Very good, Denise. Denise Kirsten, that is English and the metric system. It is called English or the British or the imperial system because this is historically used in nations once ruled by the British Empire and are still widely used in the US. On the other hand, the metric system is sometimes also called as SI. This is the standard system agreed upon by scientists and mathematicians. SI was derived from the French System International. Now, I would like to find out how far or how familiar you are in the different examples of English and metric units. We shall have a game, boys versus girls, but this activity is only good for 1 minute. But may I remind everybody not to leave this meeting. Instead, just proceed to classwork. I'll be posting the link for our group activity. Now posting the link for the mail group. And now posting also the link for the female group. Let me know please if you are now seeing those activity in the form of Google Forms. I need an affirmative response through the chat box, please. Yes po, ma'am. All right. It's 8:23 in my watch, so 1 minute starts now. Okay, for the gentlemen's group, I could see Raylan, Carl. On the other hand, for the female group, I could see Keisha. There are 3 answers already here. Dylan, just Dylan is also answering. Last 30 seconds. Time's up. Let's check your outputs. I hope the boys, as of the moment, are viewing their Google Forms. Just for one method, they have enumerated many. Under the English system, we have mile. They have given the following: mile, inches. Oh wait, probably so that the boys and the girls could see the output of the other team. I need to show the output of each group. Here is the output of the gentlemen's group. Okay, you see, they have many answers. Under the English system, miles, inches, cubic, this is incomplete po. Yards, yes. Gallons, Celsius, pounds, quart, tons, tablespoon, is this a standard unit? And ounce. On the other hand, for metric system, they gave kilometer, meter, almost all units for length. This is, we have grams for mass, liters, millimeter, and kilograms. Correct? Very good. What about in the case of the ladies? Let me show to the gentlemen the output of the ladies. Okay, for 1 minute, these were their answers. Inches, tablespoon, yards, pound, ton, ounce, Fahrenheit, pint, and quart, correct? And for the metric, centimeter, meter, gram, and so on and so forth. Very good. So it means that almost everybody are familiar with the different units, both belonging to the English and the metric system. We continue. Okay, under the English system, you are right in the answers you have given. We have this for length, the weight, the volume, density, and so on and so forth. On the other hand, for the metric system, we have also these units, which most also were given by both the ladies and the gentlemen. Okay? I would like to emphasize too that under the metric system, they introduce what we call the prefixes or the SI prefixes. The biggest is the iota, equivalent to 10 to the 24th, and the smallest is the yocto, 10 to the negative 24. But we shall be going back to these prefixes by next meeting once we are done discussing scientific notation. Why is this included here? Because this is part of the metric system. There are plenty of physical quantities in science, specifically in physics. Now, when quantity is short for physical quantities, before I proceed, let's first clarify, what is your idea of a physical quantity or quantity? Answers could be given through the chat box. What is your idea? Or you can switch on your microphone. What is your idea of a physical quantity or quantities?
Measurable and quantifiable po, ma'am.
Sige, wait. Very good, that's correct. Come again. Who was that? I have to look into measurable or quantifiable. I have to look whose microphone is switched on. Gilbert. Thank you, Gilbert. On the other hand, okay, we have Gino said numerical data. That's right. Rafael gave me samples, length, mass, time. Raylan, an amount of something po. Your answers are all correct. When we say physical quantity or quantity, it is a property of a material or anything that is quantifiable or measurable. And there are a lot, so we need to classify them. First way of classifying them is depending on the unit. The first one is called the base quantity. These are considered as fundamental in nature, and these define the standard of the other measurements. Rafael gave the example length, mass, time a while ago, and these are all considered under base or as base quantities. On the other hand, the rest are considered as derived. These are obtained by using base or fundamental quantities. In other words, when you combine two or more, you come up with a derived quantity, such as speed. I could see, Gilbert said, should have a unit. Precisely correct. It wouldn't be considered a measurement without a unit. Aside from speed, what other derived quantities do we have? Or are you familiar with? Aside from speed, I only have one example here. Force, that's correct, Marinelle. Acceleration, correct. So those are derived quantities. Now, remember this. Under the metric system, these are the only base quantities, namely mass, length, time, temperature, amount of substance, electric current, and luminous intensity. All the rest are derived, only the 7 are considered as base. I hope that is clear to everybody. Rafael and Don gave additional answers. Luminous intensity, yes, it's here as base. Volume is a derived quantity. We proceed. Another way to classify quantities is depending on the direction. It's either scalar, that is when a quantity only has the magnitude. And examples are your mass and time. Just one example. It is said to be a scalar quantity if just the magnitude provides the complete information. Example, when someone asks you, what is your mass? You simply say, I am weighing 50 kilograms. You do not say, I am weighing 50 kilograms northeast, isn't it? So that doesn't make sense. On the other hand, if it is a vector quantity, these should possess both magnitude and direction. You yourself could tell the difference that something is missing if you're dealing with vector quantities and only the magnitude is provided, such as, say, force. If we are in a typical classroom setting, I am the teacher with a table in front and you are seated on your seats. If I would say, boys, will you please help me move the table? So how will you react? Isn't it that you will be hesitant because you do not know where to put the table or to move the table? So that's one scenario where a direction is needed. But scalar and vector will be dealt in details when we go to motion in 2 dimensions. Now, excuse me. I know that in dealing with these different physical quantities, conversion, we can never do away with conversion of units. But I know that conversion of units isn't a new topic to everybody. You have been introduced to this in your science and even in mathematics subjects in the lower grades. So let's perform a group activity. First, to test how far you know, how far you could remember conversion of units. And secondly, for me also to tell how deep, how fully you have mastered conversion of units. You were already divided into 4 groups, namely the first group is Einstein, followed by Newton, followed by Faraday and Maxwell. Now, the group activity will be rated based on the criteria. Accuracy or correctness is 50%. When I say accuracy or correctness, this doesn't simply mean having a correct answer. I'll be looking into the solution or the process on how you arrive at the correct answer. Cooperation or teamwork would mean if all members tried to answer and most of the members got the correct answer. And the creativity, if time still allows, you can make your presentation presentable, the better, with a total of 20%. Okay, so let's proceed to the group activity. Do not leave the meet again. Instead, go to classwork. I'll be posting, we shall be starting all at the same time. Please wait until I am able to post all group activities. Okay? I'll be giving the go signal. Let's have first the first group, that's the Einstein group. Now posting. Second group is Newton. Now posting also. Third group is Faraday, from Michael Faraday. Now posting for Faraday. And lastly, the last group is Maxwell. Now posting also. Let me know if at the moment you are now on the link provided for your group. I need yes po, according to Marinal. Okay, listen. I haven't given yet the go signal. Okay, it is in the form of Google Slides. How will you give your answer? It's either you directly type on your answers on the Google Slides, or if not, since templates in inserting equation in Google Slides are limited, so you can get a scratch paper, use your marking pen. After done solving the problem, take a shot or take a photo and upload it in your slide. Are my instructions clear? May I know? Did you get my instructions? Anybody who can give me? Who can confirm? If my instructions, yes po, thank you for that. Okay, it's 8:37 in my watch. All groups are given 5 minutes. Time starts now. After that, agree among yourselves who will be the one to report. As you go through the activity, I'll be visiting the link of all the 4 groups. Okay. All right, I could see already 6 members from the Einstein working on this. Harvey, Aldrich, we have William, Dylan, Alejandro, and Carl are working for the Maxwell group. Faraday. Faraday group, may I remind you po, if someone is already working on the second slide, create your own slide po. Do not crowd yourselves in just one slide. Create new slides, please. Oh, you are 5 members working on the second slide, Faraday. Newton, very good. They have created several new slides already. Okay, same with the Einstein group. Okay. Let's begin with the Einstein group. Who will present? Donfer, very good, Donfer. Okay, sige, let's listen to Donfer to the Einstein group.
So
Go, Donfer.
we are the Einstein group and we are tasked to answer 1 and 2. So
Okay.
the given for number 1 is a 1.5 meter long plastic cover used as a shield is equivalent to how many meters? So
Meters or centimeters?
centimeters.
Okay.
So 1 meter, if 1 meter is equal to 100 centimeter, therefore 1.5 meters is equivalent to 150 centimeters since zero point 0.5 is equal to 50.
Okay.
So 150 centimeters. So for number 2, the standard
Okay.
size of a classroom for elementary and secondary schools must be 7.0 meters in width and 9.0 meters in length, measured from the center of the walls. Determine its area in square centimeters.
Okay.
So for number 2, 7.0 meter is equal to 700 centimeter and 9.0 meter is equal to 900 centimeter. So find we are asked to find the area. So length times width. So 700
Okay.
centimeter times 900 centimeter is equal to 630,000 square centimeter. That's all po.
Okay. Okay. Don't for before you exit. Can you please show the other slides? Can you please show to us the other slides? Okay. Oh, some outputs were not 1 meter. Okay, 150. Okay, there are other members. I could see two solutions with complete solutions, two members with complete solutions, while others were not able to finish it. Am I right, Donfer? From what I am seeing, yes po, ma'am. Okay, very good. Good job, Einstein Group, and thank you, Donfer. Okay, sige po. This time, we go to the Newton Group. Stop presenting ka na po, Donfer. Okay, thank you. Newton, from the Newton Group, who will present? Yes, Gilbert, please. Sige, you can read the problem first.
Recommended dietary allowance RDA for teens 14 to 18 years is 65 to 75 milligrams of vitamin C per day. How many grams is this RDA equivalent to?
Okay, sige. So, let's proceed to your solution.
1 grams is equal to 1,000 milligrams. 65
Okay.
milligrams times 1 grams over 1,000 milligrams is equal to 0.065 grams. Then 75 milligrams times 1 gram over 1,000 milligram is equal to 0.075 grams.
That's
Therefore,
right. Okay, good.
0.065 grams minus 0.075 grams.
Okay, Gilbert, you need not your answer is already correct. You need not subtract because you are given the range of the dosage of vitamin C. Okay, but the answers are correct. Very good. Okay, read problem number 2.
Convalescent plasma means plasma that comes from people who have recovered from an infection like the coronavirus that causes COVID-19. Say, 1 bag of plasma, liquid part of the blood, contains 300 milliliters. Convert this to letter A, centimeter.
Ah, correction po, Gilbert. Cubic centimeter po. That is cubic centimeter. Okay, sige. And here's your solution.
For letter B, 300 milliliter convert to liter. So 300 milliliter
Okay.
over 1 times 1 liter over 1,000 milliliter is equal to 0.3 liter.
All right, that's correct. Do you have other slides? Let me scroll down. Okay, someone answered here. Gilbert. Okay, continue.
For letter A, 65 milligrams times 1 gram, 1 milliliter is equal to 1 centimeter, 1 cubic centimeter. Then 300 milliliter times 1 cubic centimeter over 1 milliliter is equal to 3 times the square root of 300 cubic centimeter is equal to 6.694329 centimeter or 6.969 centimeter.
Okay, sige. Let me see whether there is another one output here from another member. Same. Same answer. That's right. Okay, let's see. Meron pa? Okay, many members worked on this.
100 milliliters divided by 1,000 is equivalent to 0.3 liters. 300 milliliters multiplied by 1 is equal to 300 cubic centimeters.
Okay, let's see. Oh, I guess that's the end of the presentation. Okay, thank you very much, Gilbert. And to the Newton group, very, very good. Excellently done. We proceed to the Faraday group. Start presenting na tayo for the Newton group. Faraday, the third group, who will? For the Faraday group, anyone? I would appreciate it if someone from your group will be the one to present at the same time explain. So you'll get used to doing it. However, if your condition now limits that, I can do the same thing with what I have done with the Newton group. Faraday, I'm waiting for someone to switch on the microphone. None. Sino po yun? Yes, Dan. Sige, Dan. Sige, kindly do the honor. Okay, there we go.
Okay, so good morning, everyone. This is the answer of the Faraday group. We were tasked to convert these the following situations. According to the 24-hour movement guidelines, teens should only get 2 hours of recreational screen time a day. Determine its equivalent in seconds. So we converted it from hours to seconds. 2 hours times 3,600 seconds, or if we were to take it step by step, from minutes to seconds, it would be 2 times 60 times 60, so that we get 3,600. I mean, 60 times 60, because 60 seconds is in 1 minute, and then 60 minutes is in 1 hour. So it's, the answer is 7,200. And in the second situation, we were asked to prove whether oil really less less dense than water, based on the its density, which is 0.93 grams per cubic centimeter, from water, which is 1,000 kilograms per cubic meter. So we converted it. So 1 gram per cubic centimeter is equal to 1,000 kilograms per cubic meter. So converting it into grams per cubic centimeter, we can get that it's greater than oil. That's all. Thank you.
Okay, thank Dan. Wait po. Can you show other slides? Or that has been the agreement of your group mates? Of your group? I see. Okay, thank you. So, congratulations, Faraday Group, and thank you, Dan, for presenting. Okay. Good job also, Faraday. And last but not the least, the Maxwell Group. Who will for the Maxwell? I hope it won't take. Yes po, Alejandro. Yes, Mr. Alejandro. Go.
Okay. Okay na po yung video? Okay.
Okay, you can present now.
Nakikita po ba?
Yes po.
Yes po.
Okay. Ulit na ba? So, good morning everyone. This is the task given to the Maxwell group. So, here are two items. First is the auto ignition of diesel at normal atmosphere is 210 degrees Celsius. What is this temperature in Kelvin? So let's see the solution of the group members. Unfortunately, ma'am, we are only three members that are able
I
to
I
see.
see.
do the work. So Carl's solution is this 210 degrees
Okay.
Celsius.
Okay.
Since if we are converting to Kelvin from Celsius, we just add 273.15 as we know. So here is 210 plus 273.15. So we get 483.15 Kelvin. So same with my solution and same with William's solution.
All
All
right.
right.
So the next question is recently, July 30, 2020, NASA launched Perseverance rover as part of Mars 2020 mission. Its escape velocity was 26,000 mph. That's mph degree, right, ma'am?
Okay,
Okay po,
miles per
miles per
hour.
hour.
Miles per
Or
hour.
Or
Okay po, okay po.
yes
yes
po.
po.
I
So,
have
I ha-
so given din po dito na 41,834 kilometers per hour po siya. So,
Okay.
ang hinihingi po, determine its equivalent in meters per second. So, we are going to convert. So, in our group,
okay.
I was the only one able to do, and I'm not sure if this is correct.
Okay.
Okay.
So, this is my solution. So, I was not able to show how did I convert it, but I just based on the metric scale
Okay.
where 41,834 kilometers is equivalent to 41,834 meters. I just multiplied it to 1,000 since 1 kilometer is 1,000 meters. So, using that data, oh, I must convert it into meters per second. So, I already have the meters. My problem left is the R. So here is my conversion. Because this is denominated by 1 hour, I must be canceling that 1 hour. So I multiplied it to 1 hour over 60 minutes where the hour unit will cancel. And then it will be divided by 60 minutes, 60. So we have the minute. So it will be meter per minute. So I multiplied it again to 1 minute over 60 seconds. So it will be denominated in seconds where the minute will cancel again and then divide it again in 60. So it will become meters per second. And here is the final value 11,620.55556 meters per second.
All right. Very good. Maxwell Group, two thumbs up for you and congratulations. Thank you, Alejandro. Though you were only three in the group, by the way, class, there were some classmates of yours who sent me a message saying that they found it too difficult to connect. That's why they failed to join us this morning. Thank you, Alejandro. And congratulations to the entire class. The four groups actually came up with all correct answers, only that there are things, some details in your solution that needs to be improved. Okay, let's continue. Congrats again, once again to the entire class, meaning I was right. Conversion of units isn't a new topic for you. We just need to revisit and to review it. Let me continue my presentation. You'll know your score, your grades for the group activity later on. I'll just revisit your outputs. Now, as we go through conversion of units, the discussion on conversion of units, let's do this in two parts. We shall begin first with the base quantities. Then after that, we shall have the derived quantities. The first one is the length. Everybody knows what is length, how it is defined. And this one, This one are what we call conversion factors. Well, do not be burdened with this long list. I do not expect that you memorize all of this right at once. But personally, may I just give this advice, that in converting units for length, at least master the units found in a ruler and a meter stick. What do I mean by that? Everybody knows that a ruler is equal to 1 foot with 30.48 centimeter. 1 foot, and it has 12 inches. 1 inch is equal to 2.54 centimeters. On the other hand, a meter stick is equal to 1 meter and 100 centimeters. I guess you'll be able to survive most conversion of units for length just remembering these most commonly used ones. After length, we have mass as the base quantity, but mass and weight in daily life are oftentimes interchanged. But be reminded that these two are exactly different. When we say mass, this refers to the amount of matter and need to be expressed in kilogram. Interchange with weight, but weight is a force that gives you the amount of the Earth's pull on your body, and this will be discussed in detail before we start with Newton's laws of motion. For the conversion factors for mass, okay, these are the most commonly used one. We have 1 kilogram has 1,000 gram. I guess the milligram here is missing, but 1 gram is equal to 1,000 milligrams. A kilogram of something has a weight of 2.205 pounds. Okay, so that is for mass. On the other hand, for time, I guess this is a quantity in which most of us are familiar. No need to memorize. These are not new to us. A minute has 60 seconds, an hour has 60 minutes, consequently has 3,000 seconds, and so on and so forth. On the other hand, for the fourth base quantity, we have temperature. You know what temperature means? It tells you how hot or cold an object is, and the base unit is in Kelvin. Unlike with length, mass, and time, for temperature, we have definite equations which could be used. Now, for temperature, we have three existing temperature scales. We have the Kelvin, we have the Celsius, and we have the Fahrenheit. How do we convert one to another? If it is, yes po. Yes po. Okay, very good question, Alejandro. Rankine is the fourth temperature scale, but we do not use that much. Thank you very much, Alejandro, for the question. You reminded me. Let me go back to the previous slide. Rankine is spelled as Rankine, is the fourth temperature scale seldom used. We oftentimes use Kelvin, Celsius, and Fahrenheit. Okay po, Alejandro, I hope I have answered your question. Okay pa, sige, we proceed. For temperature, we have definite equations that can be used, such as, if it's from Celsius to Fahrenheit, we have the 1.8 multiplied by the given temperature in degrees Celsius, added with 32. Now, if you're reading the net or reading some books, do not wonder why in some books this is found to be the 9/5. They're just the same. Okay? Then, if it's the other way around, Fahrenheit to Celsius, the given temperature in Fahrenheit, some of your classmates are still trying to connect. Okay. And this 1.8 again in some books is just the 9/5 also. On the other hand, if it's Celsius to Kelvin, which you did correctly a while ago, specifically that of the Maxwell group, you simply add 273. If it's the reverse process, of course, you subtract 273 from the given temp in the Kelvin scale. Now, dealing with these four base quantities first, how do we do conversion? We start with the simplest one, moving within the metric system or metric to metric. My dear students, can you see this diagram below here? Can you see this spot? This shows units for length, for mass, and for volume. This also shows the commonly used prefixes or units, decimeter, centimeter, millimeter. Then the bigger ones, decameter, hectometer, and kilometer. An easy way to move within the metric system is by moving the decimal point one place for each step desired. Let's have an example. Say we want to convert from meter going to centimeter. You know that a centimeter is 100th of a meter. Say the given is 2 meters. Oh, of course, if you want still to proceed to decimeter, you can do it this way. Move the decimal. Understood that the decimal point is found here, isn't it? So if it's going to decimeter, move the decimal point once, as indicated by the 10 here. So it becomes 20. But our goal is to convert that to centimeters. So moving it 2 decimal places to the right, 1, 2. So the answer is 200 centimeters. I hope you are following. Are you? I hope so. Let's have another example. Say 40.2 meters going to centimeter. Where should we move? To the right. How many times? If it's centimeter, 2 times. So 1 and 2, giving us an answer of 4020 centimeter. Another example. What if it is from meter to millimeter? A millimeter is 1,000th of a meter. Say, okay, you can disregard this portion. Say directly from meter going to millimeter. How many times shall we move the decimal point going to the right? 3. So we do it 1, 2, and 3. So the answer is 3,000 millimeters. Are you following? I need someone. Hindi pa po. Okay, now, let's resume. Sorry for the technical interruption. What's good thing about temperature as compared to the other base quantities is that here, you have definite or fixed equation already. What you'll do is simply plug in the given temperature scale. I hope this is already clear to everybody. Now, we proceed. How do we do conversion of units? We will begin from the simplest. That is, if the given is metric to metric, One simple way is simply by moving the decimal point as to the number of times depending on the unit desired. Okay, please acquaint yourselves first with this diagram found below in my slide. We have here units for length, which is meter, the base unit, the gram, and the liter for volume. These are smaller units, decimeter, centimeter, and millimeter, while on my left, we have decameter, hectometer, kilometer. Say it's meter to centimeters. You know that a centimeter is a hundredth of a meter. So if the given is 2 meters, oh well, if you still would like to proceed with, my dear students, if you would like, if I seem to talk too fast, if I seem to discuss too fast, you can give me a signal. You can tell me to, you can ask me to repeat. You can give me a warning. And it's already 9:18. We're almost 1 hour already. I guess I need to stop for at least 10 seconds or 30 seconds. May I request everybody, probably you can stand up, do some stretching so that you'll be relaxed and your eyes also will be relaxed. Sige po, 1 minute, stretch before we proceed. We're halfway with our 2-hour engagement this morning. Okay, sige po, stretch. 30 seconds. Are you doing it, my dear STEM A students? I hope so. Yes, ma'am. Okay po. We need this pose. All right. Okay na po? Gained energy already? Yes po, ma'am. Yes, ma'am. Okay, I have received many yes answers. Okay, sige, we proceed. Second example. 40.2 meters, say the given is 40.2 centimeter. We want to go to centimeter. How many zeros? 2. Where's the decimal point? Here. Move the decimal point 2 times to the right. 1 and 2. So we arrive at 4,020 centimeter. What if it's meter to millimeters? This is where meter is. This is where millimeter is. And a millimeter is a thousandth of a meter. So, how many times shall we move? 3. You can ignore this 2 already. So from 3 meters, whenever it's a whole number, everybody knows, understood the decimal point is to the right here. So move 3 times, 1, 2, and 3. So we have 3,000 millimeters. You need more examples? More. Okay, meters to kilometers. Let's check the diagram. This is where meter is, and this is where kilometer is. So, okay, I put so many numbers here. Sorry for that. Say, for example, among decameter rather, hectometer and kilometers, this is the most commonly used, isn't it? And the meter. O, sige. From meter, going to kilometers. Going to the left, with how many zeros? 3. So this is where the decimal point is. Move 3 times to the left. 1, 2, and 3. So we have this answer, 16.093 kilometers. Another example, say 240. So 3 places to the left once again. 1, 2, and 3. So we have this. Let's have another example. Say centimeter to meter. Okay, it's not from this point anymore. That is from this point. Centimeter going to meter, but still going to the left also. So how many times? 2 times. This is where the decimal point, this is the given unit, this is the desired unit. So how should you move? To the left. So that is 1 and 2. So the answer is 0.48 meters. Another, this is where the decimal point, sige, pasadahan po natin, decameter. So if it is from centimeter going to this is decimeter rather. Okay, so we move the decimal points once, decimal point rather, 1, kaya po siya naging 275 decimeter. Clarification, if it is decameter, we use DA as the symbol. If we mean decimeter, we use D. I hope that is clear. Okay? Now, going to meter, from centimeter to meter, 2 zeros, so 2 places going to the left, 1 and 2, so the answer is 27.50 meters. Lastly, let's have centimeter to kilometer. This is where our centimeter is. This is where our kilometer is. How will you do it? Can you go directly? Yes, of course. So, from centi, if you want to pass through meter first, this one. So from centi to meter, 2 places going to the left. How? Let's do it. 1, 2, so the answer is 54 meters. Then from meter to kilometer, 3 places going to the left. So we have 1, 2, and 3. So the answer is 0.054 kilometers. I hope these examples are clear. Okay, now from the examples I gave, anybody from the class who can give a rule or state the rule or the conclusion you get from the examples provided? Anyone? What shall we do if we want to proceed from left to right or the other way around? How many times should we move? Anybody who can state the rule? Okay, sige po. I guess you have all observed. Anyone? I would appreciate if the rule will come from you. If you'll be able to state your own rule. My dear STEM A, are you still with me? Are you still there? I'll give you the clue. If you want to move, going to the left. Look at these arrows. How shall we do it? Yes po. Try lang po. Wait lang po. I have to look who has switched on his microphone. I have to scroll. Yes, sino po yung nag-on ng microphone? Alejandro, yes po. Sige po. Sige po. Go, Alejandro.
If you convert it into kilometers, it will be 1. Am I right, ma'am? 1.
Pardon? The example is you said from right to left. Is that what you mean?
Right to left.
Okay, so this one, the blue one. Okay, so from right to left, where should you move the decimal point?
To the right po, ma'am.
Wait lang po. Sabi mo po from right. Okay, let's do it very slowly. You said the given unit is, sige. Take your time. Okay, begin. Sige. Restate your answer.
Okay po. So, my observation, if you have a given unit, basing on the unit scale, if you are given unit from the right, where it's milli, for example, and your
Okay.
desired unit is kilo,
Okay.
so you will be moving to the left.
Okay, that's right. On the other hand,
On the other hand, if you are given from the left, a unit left, and your desired unit is to the right, you'll be moving to the right.
that's right. Okay, sige po. Sige, let's check. Thank you, Alejandro. Let's check whether Alejandro is right. So if you're going to move to the left, ito po yun, going to the left, move the decimal point to the left. If it is going to move to the right, ito po yun na pink arrows, going to the right, move the decimal point going to the right. I hope this is clear. Let's check if it's clear. Let's have exercise number 1. Do not leave the meet, but instead, go to classwork. I'll be posting exercises number 1. Okay? I'll give you the go signal. And you are given 3 minutes to do this. Exercises number 1 is now being posted. Reminder in answering exercise number 1. The answers required are just short answers. Do not anymore include the unit of your final answer. Anyway, it is already indicated in the given problem. All right? The 3 minutes starts now. I hope you are already in the classwork for exercise number 1. All right, sige, let's see. More than half of the class are done. Let me visit the chat. Okay, done na po. Majority. Okay, sige, let's check. Let's go to our meet. As of this time, I would expect that... Have you viewed your scores, by the way? You can automatically view your score. May I know your scores, please, through the chat box? Please view your scores. Okay. A 6, very good, perfect. Majority got it correctly, meaning the method discussed is clear to everybody. Sige, let's resume. Okay. Anybody who can give us the answer for the first one? Chat box will do po. Chat box will do. For sala po paka-type ko, hehe. According to Gino. Sige po. Let's have number 1, 8,200. Very good. Donfer, Trisha, and Earl, Steven. What about number 2? I expect that at the moment you're still viewing your Google Forms for exercise number 1. 250, very good. I received 5 answers. All 250. What about number 3? Okay, I saw here 8.5, 8.50. They are numerically equivalent. I'll accept all these answers. I'll be strict with number of significant figures by next week once we're done discussing significant figures. What about number 4? 0.27. That's correct. Okay. And number 5? Number 5 is 4.7. That's correct. Lord June, Alejandro Gilbert. And number 6, 45,000. That is 45 kilometers. That is equal to 45,000 meters. Very good. Congratulations, everybody. We go back to our meet. All right. Please go back now to the meet. So these were the 6 items. Can you see now the presentation? I hope so. Okay. For the first problem, the answer is 8,200. This is for the second. This is for the third. This is for the fourth. This is for the fifth one. And this is for the sixth one. Okay? Now, I understand that when you had your mathematics class, wait po, can you please give me a minute for me to fix my extended monitor? A minute, please. A minute, please. Okay? All right, I'm back, my dear students. Sorry for this gap. Sometimes technology fails us, but of course, the show must go on. Okay, I hope you are all ready. See, we proceed, we go back. All right. May I check whether I'm really back? Can somebody give me a response if you are now seeing my presentation? Anybody? Please, through the chat box. Yes po, ma'am. Thank you for that. All right. Now, so almost everybody got perfect score. Very good. I'm so happy. Meaning, indeed, you have mastered that simple rule. Now, I know in your mathematics, you were given another way of stating the rule. Anybody who can state that? Anybody who can state that? Alejandro, Carmela, and Ella. Yes po, thank you. Okay, probably I can give you I can present this already. Okay, from this, anybody who can interpret this diagram? This is still another help, another technique whenever the given problem involves metric to metric. Anyone? Oh, I guess you can get it already from the diagram. Anybody po who can state the rule? Anyone? My dear STEM A? I know you all know this. So that, sige po. William, very good. Sige, go William.
Yeah, ma'am.
Sige
Sige
po.
po.
If when converting a number, from left to right,
Left to right.
simply multiply the number by 1,000 if it's from kilometer, 100 if it's multiply 100 if it's from hectometer,
Okay. This is centimeter.
centimeter. So
Okay.
it says, on the other hand, if given, when looking for the converted version of a number, which is from right to left, I left, I right to left, yes,
Okay.
we divide a number by 10, 100, or 1,000.
Okay, thank you, William. Yes, another way to remember. Thank you, William. Another way to remember this is true. Remembering this, if it's from a bigger to a smaller unit, you might be wondering what happened to the decameter and the decimeter. Class, among all length units, these are the most commonly used ones kasi, okay? From bigger to smaller units, you simply have to multiply it. If it's from kilometer to meter, then multiply it by 1,000. What if it's from kilometer to centimeter? You have to multiply both this, okay? On the other hand, if it is from a smaller to a bigger unit, you have to divide it such as 5 kilometer to meter, multiply it by 1,000. So the answer is 5,000 meters. So 120 centimeter, that is from centimeter, ito po yun, going to meter, ito po yun, divided by 100, so that becomes 1.2. Let's have other examples. This time, my exercise number 2 is on mass. Go to classwork again, please. Classwork. I'll be posting exercise number 2. This time, it doesn't require short answers, but rather it is a multiple type question. And since you have almost already mastered the technique, I'll just be giving you 2 minutes. Now posting. 4 po, ma'am. Marinelle. Okay, thank you, Marinelle. You got 4. Done po, ma'am. Alejandro, what is your score? 5/5, Alejandro. Thank you. Others, please. All right, let's check. Only 2 minutes rather is given. May I have your answers for number 1, please? What is your answer? For number 1, what is your answer? You are giving me the score. Raylan got 4. Okay, number 1, what is the answer? 10 milligram. Okay, very good. Carmela Grace, 0.01. What about number 2? Number 2, 5 milligram is equal to how many grams? 0.5 or 0.500, that's right. What about number 3? Yes, that's right. Just Dylan, 750, and Marinelle. What about number 4? What about number 4? 2.5. Thank you, Jess and Marinelle. And lastly, number 5. I need someone to explain the solution. Anyone? I need someone to explain the solution. For number 5 po. Yes, Alejandro. Sige po.
So since sabi po dyan sa number 5, a patient takes 500 milligrams of antibiotic three times a day for 1 week, how many grams of the medicine will he need to take to complete the medication? So, since sabi po complete medication, kailangan muna po natin kunin yung complete milligrams na makukuha niya during that medication.
Okay.
Since three times a day for 1 week, three times a day, so 500 times three, that will be for the complete day.
Okay.
Now, we will be having 1,500 milligrams for a day, but we need
Mm.
7 days to complete the week. So another times seven, so
Okay.
1,500 times seven, we get 10,500. Tama po ba?
Okay, precisely correct, Alejandro.
We need to
Okay.
convert it into, ano po yung hinihingi?
Gram.
Gram.
Grams. So, ang 10,500 milligrams po is 10.5 in grams.
Okay, precisely. Well said, Alejandro. Thank you. Okay, so in milligram, a total of 10,500 milligram, and that's equal to 10.5 grams. All right. Now, my dear students, we're done with the first simple way of converting units, that is if and only if the givens are metric to metric. But what if this time you are now asked to convert units, say from British to metric or vice versa? Can you still do the movement of the decimal place? You can give me the answer to the chat box. Say you're buying cloth expressed in yard and you want to express it in meter. Can you still do the movement of the decimal place? No na po. Okay, thank you, Alejandro. You have to employ or use another method, and that method is called the factor label method. Now, what is this factor label method? Again, you may not know this term, but some of the groups use this already. Okay, later we shall go back to your work. And how do we do the factor label method? This is a process in which you convert units, in which you use conversion factors to convert a quantity in one unit to a quantity in another unit. So, on the other hand, conversion factor is a term that converts a quantity in one unit to a quantity in another unit. When I discussed the three quantities, I have given you a list of the different conversion factors. Now, let's have, and remember that when you do this factor label method, remember two things. One, the conversion factor you should choose must relate the given and the desired quantities. And secondly, the conversion factor must lead you to be able to cancel the unwanted unit. Let's have a series of examples. This is English inches, while this one is under metric. So how do we do that? This is the given quantity, write it. While this entire quantity is the conversion factor, everybody knows that an inch is equal to 2.54 centimeter. Then, cancel this unit and you arrive at centimeter, and the answer is 18.4 centimeters. Another sample. This is again English to metric. So write the given, choose the appropriate conversion factor. For beginners po, I will allow you to once in a while look at the list of conversion factors, cancel foot, and you arrive at the answer 1.52 meters. Here comes example number 3. Oh well, this is metric to kilometer. Metric to metric po yan, ma'am. Can be converted simply by moving the decimal point. By the way, what's the answer? Someone in the chat box po, give me the answer. Moving the decimal point. Waiting for the answer. That's right, don't for 1.230. Okay, can we also solve this using the factor label method? Of course. So this is the unknown. This is the conversion factor to be used. Cancel meter, you arrive at 1.23 kilometers. Another sample, again, movement of decimal point can be done. Answer po. Answer, 20 milligrams going to gram. What's the answer? I am waiting for an answer. Oh, using the method we have just discussed a while ago. Yes, that's right. Oh, 0.02, 0.20, 0.02. Okay, sige po, let's do it. Let's check. I received two varying answers. So meaning, ang isa po dyan mali. Okay, this is the given. Conversion factor to be used is this one. The answer is this one. So cancel milligrams. Okay, some more example. kilogram to pounds. Write the given. This is the conversion factor to be used. Cancel the units. The remaining unit is pounds. This is our answer. Okay, this is for time. 80 hours is equal to how many seconds? All right, this is the given. Now, you know that an hour has 3,600. Cancel the hour. We get this answer, 288,000 seconds. But if you want to do it in details, this is how you do it. 80 hours multiplied by an hour has 60 minutes and a minute has 60 seconds. Cancel hour here, cancel minutes here, and the desired unit is second. You can do it in either of these two. Okay, now let's have other examples. This is a problem on meter going to foot. So that is metric to British. So how do we do this? Copy the given, choose or indicate the appropriate conversion factor, and we have this one, 27.88 feet as the answer. You are able to cancel the meters. Pounds to kilogram. We have also the given here. This is the appropriate conversion factor. Then cancel the pounds. We got 48 kilograms. Am I talking too fast? Or okay lang po? You are able to follow? I hope so. Yes po. Thank you, Donfer. Okay. Next sample for time. Second to hour. You can do it this way. An hour has 3,600, so cancel. We got 12 hours. Here is a word problem. Anyone can read? I'll pause for a while. Anyone can read my word problem number 4? Someone switch on the microphone po. Are you still with me, my dear STEM students? Are you there?
If you stand 5 feet and 4 inches tall, what will be your height in meters?
Thank you, Irish. Okay, this is a typical problem you encounter whenever you do your BMI in your MAPI class, I think. Okay, height is expressed in the English system 5 feet and 4 inches. But nowadays, forms, PDS, are asking our height to be in the metric or even the mass. How shall we do that? I hope everybody remembers my given, the 5 feet and the 4 inches. First, have consistency of units. If you want to do it all in feet, have it first in feet. If you want to do it all in inches, have it in inches first. Let's do the feet first. 5 feet is multiplied by a foot has 12 inches, and that's equal to 60. Cancel the foot, and we got 60 inches. Remember the other given, 4 inches. So add the 2, finally a total of 64 inches. Now to meter. From inch going to meter, a meter has this number of inches. So cancel the inches, we got this answer. Or could also be, from inch, I remember what I said a while ago, just master the units found in a ruler. So an inch has this number of centimeters, and a meter has this centimeter. Cancel the inch, cancel the centimeters, desired unit is here, finally. So you also get 1.63 meters. Or the other way around. You want it to be done in inches. So 4 inch converted to feet, cancel the inch, you got 0.33 feet. Remember the given 5 feet? To be added to 0.33, you got this. And from feet, finally to 3.28 feet, cancel the feet or the foot, and we get the same answer, 1.63 meters. You might be asking, why am I presenting all these possible solutions? Because in this topic, there is no fixed solution that you will do. You have the liberty to choose whichever is more convenient, whichever is easier for you. I hope that is clear to you, my dear STEM A students. Okay? Now, we are done with base quantities. But in physics, we deal with more derived rather than base quantities. So, we go. Sample derived quantities include those 4 problems I gave for the 4 groups. Einstein dealt with area, the Newton with volume, the Faraday with speed, and the Maxwell with density. How do we do this? Sige, let's begin with area. You know already the equation, length times width, depending upon on the surface. Let's have samples instead. 850 square centimeters to square meter. How do we do this? Okay, write the given, this one. Choose appropriate conversion factor. A square meter has 10,000 square centimeter. Cancel the unit, square centimeter, and the desired unit is square centimeter. This is our answer. But wait, you might be asking me, Ma'am, do we need to memorize again or to be familiar with a new set of conversion factors? My answer is a big no. Instead, what you have mastered for the base quantity will be enough. So how do we do that? Just remembering conversion factors for base quantities. This is how we do it. Write the given, and what you know from length, that a meter has 100 centimeter, isn't it? Just writing this quantity, can we now cancel this unit? Do not do it yet, not yet. Because this is square centimeter, while this one is just centimeter. Instead, square everything in this parenthesis. When you square everything in this parenthesis, this quantity will lead to this, simply lead to this. So meaning, you need not memorize this. Learn to derive this from what you've learned for length. I hope that is clear. Another sample, square centimeter to inch. Same process. This is the conversion factor, so you can cancel a square centimeter. But then again, go back to the basic conversion factor for length. An inch has 2.54 centimeter. Square everything. This one leads to this. And you arrive at this answer. All right? We proceed to the second derived quantity, and that is volume. It's Newton who had worked on this. Remember the convalescent plasma problem, okay? These are your conversion factors. This is quite many. Just remember the common ones. How do we do it? Let me go back. I would like to add some more. Cubic centimeter, cubic meter are units for volume. In like manner, liter and milliliters also, specifically for fluid. But it is said that in the medical field, they prefer using the so-called cc. I hope you know that. Cc po, my dear class, is just the abbreviation of the cubic centimeter, where an ml is equal to a cubic centimeter. So, Group Newton was right in their answer given a while ago. How do we do that? Okay, liter to milliliter can be done using the movement of the decimal point. But if you want to use the factor label method, a liter has 1,000 milliliter. Cancel this and this. So therefore, we arrive at 4,500 milliliters. Let's have cubic meter to cc, or cubic centimeter. We use this conversion factor for volume. Cancel the cubic meter. But if you want to derive, this again is what I am saying. This is your initial knowledge on length. Make use of this. Since this is for volume, cube everything. When you cube this will now be the conversion factor. That's the time you can cancel this unit and come up with a cubic centimeter. All right? You ready for the next? Density. It was Faraday who had worked on density. You know, density is equal to mass over volume. That's right. Okay. Here's the problem. I want somebody to read. Anyone? Trisha, can you read the problem on density?
You have a rock with a volume of 15 centimeter cube and a cubic centimeter and a mass of 45 grams. What is its density?
Thank you, Trisha. All right. Of course, from the equation, mass over volume. So we have the given mass, the given volume. We arrive at 3 grams per cubic centimeter. What if there is a follow-up question? Determine its density in kilogram per cubic meter. Sorry, this should be a superscript. Okay? So how do we convert units for density? All right, let us discuss this slowly. This is the given based here. We want to eliminate gram. So this is the conversion factor we shall use. A kilogram has 1,000 gram. We want to eliminate these two, instead get cubic meter in the denominator. So a cubic meter has 1,000,000 cubic centimeter. Do the cancellation of units. Grams are cancelled, cubic centimeters are cancelled. Finally, check your remaining units. This is kilogram, this is cubic meter. Then perform the operations, multiply all numerators, multiply all denominators, then divide. And finally, you get the answer, 3,000 kilogram per cubic meter. I guess I need to provide another sample for density. I need someone also to to read, please. Let me call others. Marinelle, can you please read the second problem for density? Marinelle? Louder po. Has Marinelle switched on her microphone already? Yes, go po, Nell.
Rocks are sometimes used along coasts to prevent erosion. If a rock needs to weigh 2,000 kilograms, about 2 tons, in order not to be shifted by waves, how big or what volume does it need to be? You are using basalt, which has a typical density of 3,200 kilograms per cubic.
All right. Thank you very much, Nell. Sorry I interrupted. Okay. Let's focus on the given first. As usual, in solving a problem, identify the given. 2,000 kilograms is the mass. This is the density of basalt. All right, so the unknown is the volume. Learn to derive equations. Density is mass over volume, but it isn't the density which is the unknown, rather the volume. So that's equal to mass over density. So plug in the givens. 2,000 kilograms the mass, and this one is the density. Perform the operation, but this time, remember that the kilograms will be cancelled. So what's the remaining unit? Is it per cubic meter or cubic meter? Someone answer me please. What is the remaining? If this is the case, what will be the remaining unit? Is it cubic meter or per cubic meter? Anyone? Per cubic meter. Very good, Alejandro. Class, if you have to rewrite these units, this will become kilogram multiplied by the reciprocal of these units in the denominator. So that will be meter cube over kilogram. So we will cancel the kilogram, giving us the unit cubic meter, which is indeed the unit for volume. At this point, my dear STEM A, I want to emphasize what we call dimensional analysis or dimensional check. What does that mean? In your solution, when we say dimensional check or dimensional analysis, you must be arriving at the corresponding correct unit for that unknown quantity. So that if in your solution, you come up with a unit kilogram squared, or say kilogram per cubic meter, or say meter cube over kilogram, the unit itself will tell you that something is wrong with your solution. So do it properly, do it correctly. When you do that, you are doing what we call dimensional analysis. Okay? But since the unknown is not in meter cube, but rather cubic centimeter, so we continue with our solution. This was our computed volume to be converted to cubic centimeter. So we cancel cubic meter, remaining unit is cubic centimeter. All right? I hope this is already clear to everybody. How many derived quantities have we finished already? May I know? Let me see whether you were listening. How many derived quantities have we finished? I'm waiting for your answers in the chat box. Much better. 3. Very good, William. Much better if you can name the first 3. Name po. Name, derive. The first 3 derived quantities we discussed. Area, volume, density. Very good, Nell. And lastly, for today, let's have speed. Okay. Speed is a quantity you have already met as early as grade 7. Okay, equal to distance over time can be expressed in meter per second, kilometer per hour, or kph, or the mph, or the mile per hour. Alright, sample problem. Someone read please. Iba naman daw po. I would like to hear a new voice. Joey, Franco, can you hear the problem po? Joey, are you there? Joey, are you there? Are you still with me? Joey is not responding. Let's have Selan. Can you read po the problem? Selan? Okay, yan na si Selan. Sige po, please read.
Maximum speed limit of a vehicle entering a school zone is 20 kph. Find its equivalent in meter per second.
Thank you, Selan. Okay po, sige. So, begin with what is given. That's 20 kilometers per hour class. In doing the factor label method, I would advise you that you write it this way in a fractional form, not like this. Why? What's the good thing of writing it this way? This clearly tell you which unit is in the numerator and which one is in the denominator, and that will facilitate cancellation of units. First, let's eliminate kilometers. So a kilometer has 100 meter, so we can cancel this. Next, an hour has 3,600 seconds. So after that, do the cancellation of units, the hours, and the kilometers, and check the remaining units. Meter in the numerator, second in the denominator. Exactly the unit that we want. So that is equal to 5.6 meter per second. If you still have time, you can check whether this is your correct answer. So, consider the 5.6, yun na solve nyo po. Then, okay, to be converted to kilometer per hour. So this time, it's the meter to be cancelled. It's the second to be cancelled. So same conversion factors, but I hope you can see the difference. Let me go back. Okay. 10 seconds, I'll show you this. Another 10 seconds, I'll show you this. Can you see po the difference of the positioning of the given in our conversion factors? May I know through the chat box? Can you see the difference? Have you seen the difference po? I'm waiting for the answers through the chat box. I'll repeat. This is kilometer per hour or kilometer per hour to meter per second. Check this out. While this is meter to kilometer per hour. Check this out also. Okay, very good. Sabi ni William, yes po, I hope so, and I hope you will remember that. All right? So, we're now done discussing conversion of units for the first 4 derived quantities. Ma'am, you said we have many derived quantities. Yes, many. But we shall go to other quantities once we reach that specific topic. Say electric current, we'll do converting units for current once we are already in electricity and magnetism. Once we are already in motion, we shall be converting other quantities also. So, this time, 2 hours given to us is almost done, but may I give you first your take-home activity. Go to your classwork, please, everybody. Classwork. I'll be posting worksheet number 2. All right. Now posting. Please proceed to classwork. And this is your worksheet number 1. And I hope you are already there. May I know, please? For your worksheet number 1, it is composed of 3 parts. The first part involves base quantities. The second part, derived quantities. And the second part is word problems. Rules or instructions. For parts 1 and 2, this just require short answers. But I'll be more strict with with part 3. You are given their word problems and you are to give complete solution. You can choose your own format in providing me your answer. You can do it on a scratch paper, take a photo, upload it. You can use the Google Sheets. You can use the Google Slides. But then again, class, in the case of the Google Slides, we have limited templates in inserting equations. So that, what am I trying to say? If you're going to go back to, I would like to show the work of every group so that you'll get my point. In using the Google Slide, we have limited templates in inserting equation. I'd like to begin with, wait po. Okay. Let's go back to Einstein group. Okay, wait po. Okay, Einstein group, just very briefly po, I would like you to go back to your work. Hello po. Can you hear me po, my dear students? I have shifted again from the PLDT to my mobile data. Okay, thank you for bearing with us. I cannot end my session without acknowledging all your works during the group activity. Allow me, please, just for a few more minutes. Okay, let me go to the work of the Newton group. All right. The Newton group deserves an applause. Have you noticed how they presented their solution? Anyone who can comment po? Look at the way how Newton did it. Exactly the same as the examples provided, isn't it? They did the factor label method, okay? Likewise, also for this one, for the volume. Very good, Newton. Okay, but not only for Newton, all groups, the 4 groups gave correct answers. But this time, I'm revisiting the process, your solution. Okay, next. I would like to show also the group of the Faraday group. For the Faraday group, okay, these were your solution, Faraday. Answers are all right. Okay, 2 hours is equal to 7,200 seconds. But then again here, you were not able to show the cancellation of units. That's the problem with Google Slide po, class. Walang template for fraction. Okay, but answers are correct. Very good. Faraday group also. And lastly, for the Maxwell group, okay, for the Maxwell group, these were the problems. Okay, they converted temperature by adding 273. And this is for the second problem. Okay, this is Alejandro's solution. The process is right, only that he had difficulty in showing the cancellation of units. All right? Now, this reminds me, I was given a signal that someone daw po a while ago was asking regarding the ranking. For 30 seconds, may I go back to ranking? Class, we seldom use ranking scale for temperature. But just for that one who asked additional information for ranking, spelled as RANKINA. If it is from degrees Celsius to ranking, this is how you do it. That is parenthesis or quantity degrees Celsius plus 273.15 close parenthesis multiplied by 9 over 5. On the other hand, if it's the reverse process, Rankine to Celsius, the quantity Rankine given in Rankine minus 491.67 quantity multiplied by 5 over 9. Okay? I can just post this in our class, in our stream, if you are still interested with the Rankine scale for temperature. All right? Now, I have seen a question here regarding the take-home activity, asking when is the deadline. The deadline will be on Friday. After this 2-hour online engagement class, the remaining hours is yours. So if I were you, you can just copy po the given. Then after copying the given, switch off your laptops or your phones po muna, do it offline so that your eyes get some rest. Then once you're ready for submission, you can just do it on or before Friday. Is that clear po, Gilbert? It's you who's asking for the deadline. Okay, meanwhile, thank you, Gilbert. Okay, now additional reminders before the dismissal. Teachers sometimes have so many reminders and instructions. As you go through the conversion of units there in your worksheet number 1, this might be of help. I'll post a material. This material is a list of conversion of units which I got as an appendix from University Physics by Young and Friedman, which is the recommended reference for General Physics 1. Have you received it? Okay. That is entitled List of Conversion Factors. I find it more useful than the ones found in the net. Okay? Then another thing is, if in case some parts of the lesson for today are not that clear to you, I downloaded video tutorials from YouTube that could be a help for you to go over conversion of units, and I am now posting it. But if you prefer the explanation I gave this morning, you can just send me a message. I'll email you, I'll send you the copy of our discussion this morning to your email addresses. I have all the copies of your email addresses. Okay? Clear po? Yes po, sabi ni Carmela Grace. And okay, wait po. My last words. All right. So these are the three parts of your worksheet number 1. Now I have given also the assignment. Now if you will notice, the assignment is already on the next topic. That is already on measurement. That is already on scientific notation and the use of SI prefixes, plus operations involving scientific notation. This was the list of conversion factors I have forwarded as material in your classroom, in our classroom. My dear students, these had been my references. Most specifically to my PowerPoint, I got it from the SlideShare and I just modified it. All right, leaving you these words. The capacity to learn is a gift. The ability to learn is a skill. And the willingness to learn is a choice. Once again, to all of you, thank you so much. That ends our lesson for this morning.